Hello, my name is Steve Bowler, and in this video I'm going to be configuring RIP version 2. Specifically within RIP version 2 we're going to be taking a look at the rule of split horizon. We're going to be taking a look here specifically within this lab. We're going to be taking a look at the example of a non-broadcast multi-access network such as frame relay and how split horizon, we're just going to be taking a look at the way split horizon is affects our frame relay network. In this case what we're going to do is we're going to have two spoke routers, router 2 and router 3, and then our hub router is going to be router 1, and we're going to be taking a look at enabling all these routers into the same subnet. So we're going to do a point to multi-point connection here using the physical interfaces, and we're going to be taking a look at the default or normal behavior of split horizon when it's run over a RIP network in a frame relay topology like we have here. So as you can see here, we have router 1, router 2, router 3. We have our network between all the routers is going to be the 172.16.1.0 network. And what we'll do now is we'll go ahead into the routers, we'll get them configured with the basic information, and then we'll go from there. So router 1, let's jump on to router 1 here. Let's go to its serial 00 interface. We'll give it an IP address of 172.16. Let's see, what are we working with here? 1.1. We'll go ahead and enable frame relay encapsulation. Then we'll go ahead and do our frame relay mapping commands. So we're doing static frame relay. So frame relay map IP 172.16.1.2, and then that's over Delcy 102. So we're doing our layer. We got our IP to Delcy mappings here. Then we'll go ahead and map to router 3. Again, we're going to allow broadcast information to traverse these links. Specified with the broadcast keyword there. Again, on router 1, if we take a look, we do already have a loopback interface. If we do show IP interface brief, we do have a loopback IP already configured. So the 1 network on router 1, router 2, we'll do the 2 network, and router 3 we'll do the 3 network. So again, on router 2, we'll just go under its serial 00 interface, do a 172.16.1.2/24. Go ahead and no shut the interface. We'll enable frame relay encapsulation, and then we'll do our static frame relay mapping commands here. So frame relay map IP 172.16.1.1 over Delcy 201. We'll broadcast that back to router 1, and then we'll also have our mapping in here for router 3 over the same Delcy 201. Okay, let's go into router 3, get it set up. Frame relay encapsulation, we'll give it the IP address of 1.3 with the /24 subnet mask, and we'll go ahead and do our static frame relay map commands. So we'll do 172.16.1.1 over Delcy 301 as broadcast, and then we'll do frame relay map IP 172.16.1.2 over the same del C301. Again, if we do a show IP interface brief on router 3, we already have a loopback 0 interface here as the all 3 network, and then on router 2 we should have the all 2 network for the loopback 0 interface. Okay, so let's go ahead and take a look. Let's first take a look and analyze the rule of split horizon and how it will be affecting our network here. The rule of split horizon is pretty simple. Basically saying that updates received on an interface will not be sent out that same interface. So all these routers are using their serial 00 interfaces to connect to each other over the frame network. So basically this rule is saying if router 2 sends an update out to router 1 and router 1 receives that update on its serial 00 interface with split horizon enabled, that update will not be able to be sent back out that same interface in which it was received. In this case it was the serial 00 interface, and sent back to router 3. So what can happen here, as you might have already figured out, is that say router 2, say we put a couple of networks on router 2 and advertise them into RIP. Well, these networks will not be able to propagate from router 2 to router 1, and then from router 1 to router 3 if the rule of split horizon is actually enabled on the interface. So again here, when we're talking about RIP, we're going to see that it is enabled on all interfaces by default except for the main physical interfaces in this non-broadcast multi-access network type frame relay. So we're going to take a look at this, how you can verify this, and how we'll be able to see split horizon in in action. We'll disable it, enable it on the interface on router 1, and we'll just take a look at its properties here. So again, on router 2, we'll just put in our loopback 0 network here, so that we're aware of where these networks are coming from. Loopback 0 is the all 2 network on router 2, and router 3 loopback 0 network is simple, it's the all 3 network. Okay, so now what we'll do is we'll go ahead and just enable RIP on all the routers. On router 1, we'll do a router RIP. We'll do a no auto summary to disable summarization at classical network boundaries. Then we'll go ahead and do the version 2 command, which allows us to send subnet masking information in our updates. Also allows for more other things within RIP, but we're not going to be concerned about those right now. So let's go ahead and put our network here. So 172.16 is our network that connects us with all of our neighbors, and we don't even need to add the loopback 0 on router 1 at this point. So we'll go ahead and not specify that network statement right now because we don't need it as of yet. Alright, so let's go here on the router 2 and do the same thing. We'll enable RIP on router 2. Put in version 2, no auto summary. Very important 2 first commands with RIP. Then we'll do a network 172.16.00. And then we'll also want to advertise our loopback 0 interface here, so we'll do the network command for it, which is the 2.0.0.0, and that should be it. Let's go into router 3. We'll go ahead and enable RIP as well on router 3. Again, here we're going to put in our network statements 172.16.0.0, and then a network command here for the 3 network, and then we should be good to go. So now with this simple configuration, if we go into router 1, if we just do a show IP protocols, what we should see here, and we do our routing information sources. One of the ways we can verify our RIP neighbors. We see our gateways here, which is our peers. We see router 3 and router 2. It gives us the distance, which is the default 120 administrative distance for RIP. And if we go to router 3, we'll do the same thing. We show IP protocols. We see router 1 as a neighbor, gateway, and same thing on router 2. We see router 1 as well as a neighbor. So let's go ahead and take a look at the routing tables and see what is going on with split horizon, and if it is indeed affecting this network right now. On router 1, if we do a show IP route, you can see that I am learning of my RIP routes from both of my neighbors, router 2 and router 3, and I'm able to ping them with no problems. And let's go ahead on router 2 and take a look on router 2 and see if I can see router 3's loopback. And as you can see here, we are seeing router 3's network. And we can see that it is 2 hops away. So of course it's going to go through router 1 and then to router 3. So if I can go ahead and try to ping this, you see I have reachability. And what we're going to do is we're going to take a look at, why, if split horizon is a rule within, RIP, why is, these networks being able to be seen on these spoke routers. So why on router 2 am I able to see router 3's network if router 3 sends an update to router 1, and by default, if router 1, the rule split horizon, router 1 should not be able to send out updates in which it received an update from an interface. So if router 3 sends updates to router 1 via router 1's serial 00 interface, split horizon tells us that it should not be able to, router 1 should not be able to send this network back out, its serial 00 interface back out to give this update to router 2. But as we can see here in our routing tables, on router 2, we're seeing the 3 network, and on router 3, if I do a show IP route, we are indeed seeing the 2 network. So this is different and should be noted than the default behavior in EIGRP with split horizon. I do have a EIGRP lab where I go over split horizon. I can't think of the lab number right now, but if you have my my labs, you can take a look and see which one that is. In EIGRP, with the same network type, point to multipoint over non-broadcast multi-access frame relay network using physical interfaces, this outcome that we see here will not be shown. We will not see each other's the spokes updates being received. So on router 2 we shouldn't see router 3's network, and then the same thing on router 3 we shouldn't see router 2's network. And I'm going to show you why in RIP version 2, or in RIP here, why this is allowed. If we go to router 1, we can do one simple command to show this, which is show IP interface serial 00. What you can see here with this very simple command gives us a lot of good details, access lists, multicast information, policy routing, header compression if it's enabled. A lot of good information with this command. Show IP interface serial, and then just put in your interface name. Specifically within this command, what we're going to be looking here at is the split horizon option. So what we can see here on this interface, we're seeing split horizon is disabled. And that is why we are able to see on router, these networks and these updates being processed by router 1 on its serial 00 interface and then being sent back out. Because within, RIP, when we're running this network type on a frame relay connection, on the physical interfaces, we're seeing split horizon being disabled. So let's go ahead on to router 1. Let's just try to break the network here. Let's see if I want to do a debug command to see if we can see any of this information. Yeah, let's do this real fast. If I do a debug IP RIP on router 1, let's go to router 3. You can see here that it's receiving, update. From here it just received an update from router 3. Anyway, let's go ahead and do this. And then you can see it sees an update from router 2 here. So let's go to router 3. Let's go ahead and add another network here. We'll do interface loopback 33. Just give it the IP address of 33.33.33.33 with a /24 subnet mask. And then we'll go ahead under RIP. We'll do a network 33. And now what we should see on router 1, as we saw real fast here, we're seeing that it is, let's see if I can stop this information here. Alright, so if we go back here, once we put in the 33 network to, in router 3 and advertise it into RIP, what we did see here is on router 1 we did receive the update from router 3 for the 3 network. And what it did here is it went ahead, sent this out, as a flash update to its, multicast address here, which is 224.0.0.9, back out serial 00. So let's go ahead and do this here. If we go into router 1 and we enable split horizon, let's go ahead and see what this does to our network here. Now if we go to router 2 and just do a show IP route, you can see here that we are still seeing the networks. I might have to do a clear IP route in the routing tables. Let's go back to router 2. And as you can see here, we're not seeing any of these networks right now yet. Except for, of course, router 1's network that it's advertising via RIP, we are able to see but from, because that's directly from the hub. So of course we're going to see that update from the hub, but from spoke to spoke, what we can see here now is when we enabled split horizon, we are not able to see the spoke networks being advertised via RIP on the spokes. So again, router 2, I'm not seeing any updates at all. I'm not seeing, router 3's loopback, and then on router 3, I'm not able to see, router 2's loopback at all. And on router 1, as you can see, router 1 can see all the networks and should still have reachability here. Looks like right now we do have a reachability issue with router 3. Let's go ahead and take a look. So we should see on router 3 let's go ahead and try to ping from router 3. Let's go ahead and ping router 1. Looks like we have, okay, there we go. Alright. On router 1, if we do a clear IP route, let's go ahead and clear this again. Okay, let's see here. If you might be wondering what I'm trying to do, I'm just trying to realize why router 3 is not seeing router 1's loopback. And it looks like, okay, let's look on router 2 again here. Okay, here we go. Don't know what happened. That's fine though. It says here it's possibly down, and that's because, router 1 isn't advertising the 1 network. I thought it was in there before, but I guess it is not. It was not, so that's fine. So I guess what we can do is what we can do now is go back to what we were talking about earlier. With router 3 and router 2, they're not able to see each other's RIP routes. And that's because on router 1 we went ahead and enabled split horizon on its serial 0 interface. So what this is doing again, router 2 is sending an update to router 1. Router 1 is processing that update, and we can see that in router 1 if we do a show IP route. We can see those networks, but we cannot, if we're using the concept of split horizon here, router 1 is not going to send out an update in which it received an update on its same interface. So router 2 sends it to router 1 serial 00 interface, and then router 1 says, oh, I cannot send this back out the same interface in which I received it on, because split horizon is enabled. And that's why we cannot see on router 3, we cannot see router 2's network, and we cannot see on router 2 router 3's network. Again, router 1 though has reachability. We can ping just fine, all the networks. So let's go ahead. Before, as you could see, those flash updates, you could see a lot of stuff here. When we had split horizon disabled, we saw the update. When we added the 33 network on router 3, we saw the update come in. Then we saw, the update go back out the same interface on, via the broadcast address. I'm sorry, multicast address of RIP version 2 back out the same interface in which it was received upon. And that's because by default, split horizon is disabled on the serial interface here. So what we did is we went ahead and manually broke this network so that we can get a more detailed look and see why, what is occurring and why. So if we go to router 2 and go ahead and add a loopback interface here, loopback 22. What we can do now is go into RIP. We'll advertise the 22 network on router 2. Oops. And as you can see here on router 1, we're still waiting here. We don't see any information. So if I do a show IP route, we can see the update here on router 1. So if I do a show debug, just to make sure I have debugging. Actually, I thought I had. Let's do this. Don't know what happened with my router here, but let's go ahead and do a no network. Clear the routing tables here. And what we'll do is we'll do a debug IP RIP on router 1. So let's do a show debug, make sure we have that on here. So RIP protocol debugging is on router 1, and we'll go ahead back into router 2 now, and we'll do a network 22000. And as you can see here on router 1, we are seeing, like we did before, we are seeing with the debug information here, we received a version 2 update from router 2. And we updated our routing table with the 22 networks. If we do a show IP route on router 1, you can see here that we just updated our routing table with the 22 network, and we can ping it with no problems. And as you can see, just like before, looks like we're sending the version 2 update via multicast, out serial 00. Now we do see here where it says build update entries suppressing null update. So let's go back here and we'll go ahead and create another loop back here, the 12 on router 2. And what I'm trying to get at here is to see if it's actually showing us in these debug commands, that it's not going to send this information out the same interface which it received when we have split horizon enabled on the interface. So what we need to do here is add another interface on router 2, loopback 12. It's all 12 network. And what we'll do is we'll go ahead and we'll just take note here of what we saw. We'll copy this information into Word when we advertised the 22 network, and then we'll go back here into router 1. We'll do a interface 000. Actually, let me show you this again. If I do a show IP interface 000, what we can do see now is split horizon is enabled on the interface. And when the 22 network we just added into router 2, if we go on to router 3, we'll do it on all. We don't need debugging on router 3. If I do a show IP route, as you can see, router 3 is not receiving those updates. So router 1 is suppressing those updates from going back out the same interface that it was received upon, and that's because we have split horizon enabled now on router 1's serial 00 interface. So let's go back on to router 1. Let's go ahead and do a no IP split horizon. And now on router 3 we should see the RIP routes and be able to ping to them. Okay, there we go. So now you can see once we took, disabled split horizon on the interface, now you can see that router 3 is learning of the RIP routes from router 2. And we should see vice versa here on router 2. We should see router 3's networks as we do. So that's a quick look at split horizon. I'm just going to try to show you one more thing here. Hopefully this works out for us. You can see again here split horizon is now disabled on router 1. So let's go ahead and do this here. Let's do a debug IP RIP, and on router 2 we'll go ahead and advertise that 12 network into RIP and see what happens here. Alright, so a lot of different information is what we're getting now, and I think this is exactly what we wanted to find out here. Let's go ahead and paste this here, and then we'll go ahead and talk about what is exactly going on here with this 12 network. What we can see here is with the 22 network, when split horizon was enabled on the interface, what we're seeing here is router 1, from router 1's debug information, router 1 was receiving these updates right away when we added the 22 network. And then you can see here that it was trying to send this version 2 update via its multicast address back out the same interface in which it was received upon. But then what you can see here is we get this command here within RIP output saying building update entries and then suppressing null update. So what I'm guessing is going on here is that when with split horizon enabled on the interface, these updates aren't being allowed to go back out the same interface in which they were received upon, and that's why suppressing means that basically these routes, this route in particular, the 22 network, is being suppressed from going back out the same interface, which was serial 00, in which it was learned upon. And what we did to try to further see if this was exactly the correct information is we went ahead and we disabled split horizon, then we added another network on router 2, the 12 network, then we debugged again on router 1 where we received the version 2 update from router 2, which was the 12 network. Then what we saw here is that the same command again, we saw the sending version 2 flash update to the multicast RIP address out serial 00. However, this time we did not see this statement here, build update entries suppressing null update. What we saw here is just build flash update entries. So and then you can see here we received a version 2 update from router 3. See, router 3 is trying to say, hey, look, I have the 12 network as well. It's reachable via me via 3 hops away. So, of course, these updates are now, with split horizon disabled, these updates are being sent, from router 2 to router 3. Then now router 3 is turning around and advertising them as saying, hey, I know how to get to the, the 12 network as well. So very interesting information we can see here by just doing one simple debug command on the hub router here in our RIP split horizon lab. So again, as you can see, these updates are being suppressed when split horizon is indeed enabled, and then when split horizon is disabled, which is the default with RIP on the physical interface here in this frame relay non-broadcast multi-access network type, you can see that these networks are being allowed to be sent back out the same interface in which they were received upon. And then you can see here router 3 is going around and trying to advertise it, the 12 network as well. So again, this is our RIP version 2 lab here, where we just went over split horizon. We pretty much broke it down. We showed you how you can take a look at it and monitor it at the interface level. And also we went ahead and advertised some networks into RIP, and we just watched the behavior of RIP. When we advertised some networks into RIP with split horizon enabled on the interface and with split horizon disabled on the interface, and we verified the information with debug command, and we also looked at IP reachability and our routing tables on all 3 routers. So I hope you guys have enjoyed this video, and I'd like to thank you for watching.